All right, let's dive into something pretty amazing today. Energy harvesting.
Wow, yeah.
The kind that could, maybe someday gain batteries obsolete.
Yeah.
Like, imagine your phone charging just from you walking around.
Yeah.
That sounds pretty wild, right?
It does, but it might be closer than you think.
Really?
Yeah, it's not just a sci-fi thing,
Oh, okay.
Energy harvesting is already happening,
Huh.
and it could really change how we power our electronics.
I've got a bunch of research here about it.
Okay.
About piezoelectric and triboelectric materials.
Right.
They seem to be like the key players in this whole energy revolution.
Yeah.
But, to be honest, I'm kind of curious about the basics of piezoelectricity.
Okay.
Just the name itself sounds kind of intimidating.
I know, right? It's a mouthful.
Yeah.
But it's actually a pretty simple concept.
Okay.
So think of it like this.
Okay.
Certain materials have this special crystal structure,
Okay.
and when you squeeze them, stretch them, or even just vibrate them,
Yeah.
they generate an electrical charge.
Oh, wow.
It's kind of like they have this hidden energy just waiting to be released.
So it's not like some chemical reaction happening.
No.
It's like a physical change in the material that's making the electricity.
Exactly. And this isn't just theoretical stuff.
Oh?
Piezoelectric materials are already being used in things we use every day.
Like what?
Well, like those clicky BBQ lighters.
Yeah. Yeah.
That's piezoelectricity in action. And even the microphone in your phone uses it.
Really?
Yeah, to convert sound waves into electrical signals.
Okay, that's pretty neat.
It is.
But how do we go from, lighters and microphones to powering something more complex?
Right.
Like, say, a smartwatch or something.
Okay.
What are the limitations there?
That's a great question.
Yeah?
It's where things get really exciting,
Oh.
but also really challenging.
Okay.
See, to power a smartwatch, you need a consistent and reliable energy source, right?
Right.
And while we move around every day and create vibrations, capturing enough of that energy to actually run a smartwatch?
Yeah.
Well, that's a big hurdle we're still trying to overcome.
So researchers are working on that?
Oh, yeah, definitely. They're trying to improve the efficiency of piezoelectric materials,
Uh-huh.
looking for, compositions that produce more energy
Yeah.
from smaller movements.
So it's about finding the right material.
That's a big part of it, yeah.
Uh-huh.
And then kind of optimizing it
Yeah.
to get the most electricity possible from, even the tiniest vibrations.
So it's like fine-tuning an engine.
Yeah,
You
exactly.
get the most power out of every drop of fuel.
You got it. And it's not just about the materials themselves either.
Oh.
How we design them and integrate them is really important too.
Like how?
Imagine weaving these flexible piezoelectric fibers into clothing.
Wow.
Then just the subtle movements of your body could charge your devices.
That sounds like something out of a movie.
I know, right?
Like sci-fi or something.
That's pretty amazing.
But I imagine there's still, big challenges to overcome, right?
Yeah, there are. Scalability and durability are two of the big ones.
Meaning what exactly?
Well, we need to figure out how to produce these materials affordably
Okay.
and on a large scale, right?
Right.
And then we also need to make sure they can, hold up to the wear and tear of everyday use.
That makes sense.
Yeah.
Okay, well, let's shift gears a bit here.
Okay.
What about triboelectric materials?
Sure.
I understand they work a little differently, right?
Yeah, they do. Piezoelectricity is all about pressure, remember?
Uh-huh.
But triboelectricity, it's all about friction.
Mm.
Like when you rub a balloon on your hair
Yeah.
and it sticks to the wall?
Oh, yeah.
That static cling,
Yeah.
that's the triboelectric effect.
Wow.
It's creating an electrical charge just from rubbing two different materials together.
So instead of pressure making electricity, it's that rubbing or contact that does it.
Eggs.
Hmm.
And this, seemingly simple phenomenon,
Yeah.
it has huge potential for energy harvesting.
Really?
Yeah, there are these things called triboelectric nanogenerators, or TANs.
Tanes?
Yeah.
Okay.
They're these tiny little devices that capture this frictional energy
Yeah.
and then convert it into electricity.
So can you give me an example of, how a TAN would actually work?
Sure. Imagine a sensor, right?
Okay.
Embedded in a roadway.
Okay.
So as cars drive over it,
Yeah.
the friction between the tires and the sensor generates an electrical charge.
Oh, wow.
And that charge can actually power the sensor itself, letting it collect traffic data without needing any, external power source.
So it's completely self-powered.
Yeah, pretty cool, right?
Yeah, that's a great example.
Thanks.
So for that kind of application, are TANs more efficient than piezoelectrics?
It really depends on the specific application.
Okay.
Piezoelectrics might be better at harvesting energy from consistent rhythmic movements.
Okay.
Like your heartbeat.
Right, right.
TANs, on the other hand, are better at capturing energy from random intermittent movements.
Like what?
Like footsteps or wind gusts.
So each has its pros and cons, I guess.
Pretty much, yeah.
What are some of the big challenges facing TANs then?
Well, similar to piezoelectrics,
Yep.
scalability and durability are key.
Uh-huh.
Finding the right combo of materials,
Okay.
ones that generate a strong triboelectric effect.
Right.
And that can be produced, cost effectively
Yeah.
and can withstand being used over and over again.
That makes sense.
That's crucial, but researchers are making a lot of progress here.
Oh, yeah.
Yeah, they're exploring like all kinds of innovative materials and designs,
Like what?
like, micro and nanostructured surfaces
Okay.
that enhance, friction and charge generation.
So it's a mix of material science and clever engineering.
Exactly. It's like solving a puzzle,
Yeah.
trying to find the right pieces and put them together in just the right way
Right.
to make this really powerful and efficient energy harvesting system.
That's amazing.
It is.
Well, this is all incredibly fascinating.
I'm glad.
We've covered, like, the basics of piezoelectrics and triboelectrics,
Right.
but I want to know more about, the cutting-edge research and the potential applications.
Okay, yeah.
Like, I'm super interested in that self-powered wearable tech we talked about.
Yeah, that's a great topic. Let's explore that next.
Sounds good.
Okay.
All right, so we've talked about the basics, piezoelectrics squeezing out electricity, triboelectrics making sparks from friction.
Right.
But what about the applications? Like, how is this going to change our lives?
Well, wearable tech is one area that's really exciting.
Okay.
Just imagine, like, a smartwatch that never needs to be charged
Wow.
because it's powered by your wrist moving around.
That would be amazing.
Or fitness trackers that, get their energy from your heartbeat.
No more charging cables. That would be a huge deal.
Totally. No more worrying about battery life either.
So how are we getting closer to this? What's happening in research?
Well, researchers are developing these super thin and flexible piezoelectric materials
Okay.
that can actually be woven into fabric.
Wow.
And they're also looking at biocompatible materials.
Biocompatible.
Yeah, so they can be implanted under the skin.
Under the skin.
Yeah, to power medical devices.
So, like, what kind of devices are we talking about?
Well, think about pacemakers
Okay.
that never need battery replacements.
That would be incredible.
Or biosensors that are constantly monitoring your health
Wow.
and sending that data to your doctor
Wirelessly.
wirelessly. Yeah, it could really revolutionize healthcare.
It really does sound amazing.
It is.
Okay, but what about applications beyond our bodies?
Right.
Where else could this technology be useful?
Smart cities is a big one.
Okay.
Imagine sensors embedded right in the roads, harvesting energy from the cars driving over them.
Oh, wow.
So those sensors could like monitor traffic flow, detect accidents,
Yeah.
even control traffic lights to make everything more efficient.
So our cities could be not only smart, but also self-powered.
Exactly. Pretty cool, right?
Yeah, that's incredible. What about harnessing energy from, like, the environment in general?
That's another area with a lot of potential.
Okay.
Researchers are developing 10Ns that can harvest energy from all sorts of things,
Like what?
like wind, rain, even ocean waves.
Oh, wow.
So you could have buildings that generate their own electricity
Really? Just from the wind?
from the wind blowing against them, yeah.
It seems like we're on the verge of some huge changes in how we get energy.
It really does, yeah.
But with all this amazing progress, are there any downsides we should be thinking about?
Well, of course, no technology is perfect. Like,
Right.
one concern is the environmental impact.
Okay.
Some of these materials require rare earth elements.
Yeah.
Or they need complex manufacturing processes
Right.
that could have, a big ecological footprint.
So it's not a perfect green solution?
Not necessarily, no. We have to figure out how to make these materials sustainably
Yeah.
and look for more readily available materials to use.
Right.
But there's a lot of research going on into that, finding biodegradable and recyclable options.
What about the devices themselves?
Good question.
How long do they last?
Yeah.
Will they just end up as more e-waste?
That's a valid concern, yeah.
Yeah.
Especially if they're integrated into clothing or, implanted in the body.
Right.
We need to make sure these devices are durable,
Yeah.
that they last a long time.
And that they can be recycled, right?
Exactly. Recycling and figuring out what to do with them at the end of their life is super important.
Okay.
And that needs to be considered early on.
So it's more than just the science of it all.
It is, yeah.
It's about making sure this technology actually benefits everyone.
Right?
And the planet, too.
Exactly. It's about finding that balance between, technological advancement and being responsible towards the environment.
So as we learn more about energy harvesting, what's the most important thing you want our listeners to remember?
That's a tough one. I think the key takeaway here is that this isn't just about replacing batteries.
Oh.
It's really about changing how we think about energy.
Okay.
It's about creating a world where energy is abundant and everyone has access to it.
And it's sustainable, right?
And it's sustainable, yeah. And even though there are challenges,
Yeah.
the research is moving so fast.
That's exciting.
It really is. It's a super exciting field to be in right now.
Who knows what amazing things are coming next?
Exactly. The future of energy is closer than you think.
Yeah, it feels like energy harvesting could really change everything. But I guess, like anything new, there are some downsides, right? Maybe some risks, too.
Yeah, you're right. It's important to think about that. Even with all this potential, there are things we need to watch out for.
Like what?
Well, one thing is the environmental impact of actually making these materials.
Oh, right.
Some piezoelectric and triboelectric materials, they use those rare earth elements, or
Yeah.
they need these really complicated processes to make them.
Yeah.
And those things can have a pretty big effect on the environment.
So it's not a totally green solution then.
Not always, no. Not unless we can make them in a sustainable way.
Right. So what do we need to do?
We need to figure out how to make these materials in a way that's eco-friendly.
Okay.
And we need to find different materials that are more readily available.
To lessen the impact, right?
Exactly. But people are looking into that. There's a lot of research happening in that area.
That's good.
Yeah, finding biodegradable and recyclable options. So it's getting better.
What about the devices themselves?
Okay, yeah.
What about them? Are they going to last?
That's another good point.
Yeah.
We don't want them to just become more e-waste, right? Especially if we're talking about putting them into clothing or inside the body.
Right.
Durability is really important.
They need to last a long time.
Yeah, they do. We need to make sure of that.
And be recyclable too, right?
Exactly. Figuring out how to recycle them and what to do with them when they're done, that's super important.
Yeah.
And we need to be thinking about that from the very beginning.
So it's not just about the science, really.
It's not, no.
It's about the bigger picture.
Yeah, it's about making sure this technology helps people.
Right?
And helps the planet, too.
Makes sense. So as we finish up our deep dive into energy harvesting,
Yeah.
what's the one thing you hope people will take away from this?
Ooh, that's a good question. I think the big thing to remember is that energy harvesting isn't just about getting rid of batteries.
Okay.
It's much bigger than that.
It is.
It's about changing how we think about energy as a whole.
Oh, I see.
It's about creating a world where there's plenty energy for everyone.
And it's all sustainable.
And it's sustainable, yeah, and even though it's still early days,
Right.
and we have challenges to figure out, the research is moving so fast.
It's exciting to think about.
It really is.
Who knows what's next?
The future of energy is, well, it's closer than we think.
So there you have it, folks. A look into the world of energy harvesting. Power from movement, friction, and, all that human ingenuity. Stay curious.